Segmentation is the process that enables us to extract anatomical features that we will need from the DICOM data. We will click on the segmentation tool, and in this example, we will be focusing on the bone segmentation process. The first step is to establish the threshold setting. The threshold is adjusted by manipulating the upper and lower threshold bars. As we begin adjusting the lower threshold, you will see the changes reflected in the volume in green. As we increase the threshold, you will notice that only high-density areas are highlighted green. As we decrease the threshold, the green begins to include the soft tissue information as well. In this example, our goal is to extract the bone. Therefore, we will manipulate the threshold until we achieve a well-defined, uninterrupted green boundary for the bone. In this case, we are not particularly concerned with the internal aspect of the bone. By utilizing the Fill Holes tool, the software will create an outer boundary following the surface of the bone and remove any particles inside. This creates a nice model for 3D printing. Once the threshold is satisfactory, we will click on Bone Segment, and it will create our bone segmentation model. If we hide the threshold, we can observe that the surface of the bone model is represented in the volume by the red outline. We can also notice that the software created a second object due to an artifact present that was not connected to the rest of our bone anatomy. However, it was captured during the threshold process. We can choose to visually turn the object on or off, and we are able to rename our objects as well. We will go ahead and rename Bone 1 to Mandible so that it is clear which object we are working on as we continue through the next steps. We will now turn the threshold back on and click Next Step. We are now presented with a variety of tools that will allow us to edit and refine the model's surface. For example, we can see that the surface of the model is quite rough, so we can easily use the Smooth tool to have a better representation of the bone. We can also see that there are quite a few artifacts on our segmentation that require additional processing. The free-form modeling tools available in segmentation are subdivided into 3 categories. The 3D brush tools will edit the model on both the 3D and 2D level. Let's take a look at the 3D smooth brush. The diameter setting will affect the area of your brush, while the strength setting will affect the intensity of the tool per click. In addition to sliding the bar, we can also use some shortcut keys. Holding Shift while scrolling the mouse wheel will adjust the diameter, while holding Control and scrolling the mouse wheel will adjust the strength. These tools are quite powerful, so for now we will start off with the lower strength setting. We can begin left-clicking the different defects to apply our Smooth tool, and can begin working throughout our segmentation, rotating as necessary. As mentioned previously, the tools in the 3D brush category work on both the 3D and 2D level, So you can see that we're able to address the defects in the 2D CBCT views as well. Another important tool is the Fill tool, which allows us to fill gaps in the model. We can begin evaluating our segmentation for any gaps that may impair the 3D printing. In general, the quality of the original CBCT scan plays the greatest factor in the final quality of the rendered segmentation. If we do need to take a more precise approach, we can utilize the tools in the 2D brush category. In this region, we can see that there is some scatter extruding off this molar. The 2D brush has the ability to add material via the Paint tool and remove material via the Erase tool. The Hounsfield unit brush allows us to adjust the threshold locally. As we hover our HU brush over different areas, we can see that it is revealing our green threshold that we established earlier in this video. We are able to change these threshold values locally by adjusting the values in the threshold setting to the left and then clicking on the desired area to apply the new threshold setting. The inner circle in the HU brush represents the Paint tool, which we are able to use in conjunction with the HU brush itself. For example, let's pretend that we accidentally removed too much area in the segmentation. We are able to hold Shift to activate our Paint tool and left-click to add material back into our segmentation. This allows us to make these edits without having to manually select the Paint tool on the left-hand side. Therefore, we are able to work very accurately and efficiently with both brushes simultaneously. With these various tools at our disposal, we can continue to work throughout our model to address all of the defects. We also have a traditional cut tool, which allows us to divide the segmentation into different parts, whether that's for visualization or 3D printing purposes. We can begin left-clicking to specify the area we wish to cut, and select Save Cut Parts if we want to keep the highlighted area after cutting. Now we can see that our arch has been cut into two separate segmentations. If all segmentations are highlighted, the Cut tool will cut through every single segmentation. However, if only one segmentation is selected, the Cut tool will only affect that specific region even if other segmentation areas are encompassed. Once satisfied with the segmentation, we can click Finalize, and we will also be sure to save the project. Now our segmentations have been updated to STLs and are visible in our Objects menu. We can even right-click and toggle wireframe to view the triangle mesh, confirming that these are indeed STL files ready for 3D printing.